Okay, so first thing we want to do is define what is a unit circle. Why is it called a unit circle? So we're going to write a few characteristics down really quickly about the unit circle itself. Okay. First of all, the unit circle has its own equation. X squared plus y squared equals what? The original equation for a circle, or the general equation for a circle, looks something like x minus h squared plus y minus k squared equals r squared. You maybe saw that in geometry. Does anybody remember then, like, what is the center of this circle? From that equation.
Is it HK?
It's HK, and in this case, HK would be 0, 0. So the unit circle is centered at the origin. That's probably everybody's favorite type of circle anyway, to just go out from 0, 0, right? Okay, so centered at the origin. What's the radius of our circle? 1, because r squared should be equal to 1, therefore r must be 1, right? You always have to take the square root of that number in the equation. So your radius is 1. That's why it's called a unit circle. So in math, when we talk about unit, we mean 1, a single. Okay, so when we're talking about the unit circle, we're talking about the most basic circle with a radius of 1. Okay, now xy is any point on the unit circle. Okay. Xy is any point on the unit circle. So I could, if I wanted to, just really quickly, draw a quick sketch of what I'm then talking about here. Here's a coordinate plane. My center of my circle is right there at 0, 0. And then I have a radius of 1 all the way around. Okay, that's what a unit circle is. If a circle has a radius of 2, then it's no longer technically the unit circle. Okay. Using that information, we can go to our unit circle and we can fill out a few things. Okay, so have your yellow unit circle now. Okay, we're going to fill out some things on the unit circle. And I know that, like, the way this room is set up, I might be in your way at some point. So you just have to tell me, like, if I need to slide stuff up. Okay. Okay, so one thing I'm going to do just really quickly is at the center there, I'm going to go ahead and label that. That would be like 0, 0. Okay, and then you can imagine like your vertical y-axis and your horizontal x-axis crossing through that center point. Okay. If we know that this is a unit circle, so it has a radius of 1, we can identify a few points right off the bat. What is this point over here? 1, 0. If we go up, then we're at 0, 1. If we go left, we're at negative 1, 0. And if we go down, then we're at 0, negative 1. Okay, so we can easily label those 4 points. The other points around the unit circle, those are going to be a little bit harder for us to find, and that's what we're eventually going to use our pink and blue triangles for, identifying the coordinates of those points. Okay. Before we do that, let's go ahead and label angles. Okay. So I'm going to talk first about just the first quadrant. Okay. So I'm going to go into the first quadrant right here. Okay, that's these angles right here. If this is my initial side, okay, and my terminal side lies on my initial side, I don't open my angle at all, then I would have a 0 degree angle. This angle is part of the special right triangles, and so it's a 30 degree angle. This angle is 45 and then 60. And then we go up to 90. So you can see like this angle does sort of cut that first quadrant in half. So it's 45 and 45. And then you can also see like you have some thirds. Here's 1/3. Here's 2/3. And here's 3/3 of 90. So those are each 30-degree angles. Okay. We could also put those as radians. So if I were doing those as radians, I might start off by using like a conversion, multiply by pi over 180. Bless you. Okay, if I multiply by pi over 180, 30 times pi over 180 would leave me with the fraction 30 over 180, 3 over 18, which reduces to 1 over 6, and there'd be a pi. So this is really pi over 6. If I were to do 45 times pi over 180, I can reduce that, and 45 goes into 180 4 times. Okay, so this will reduce to be pi over 4. It's 45 plus 45 is 90. Okay, and then you get another 2 in there. And then same thing, 60 times pi over 180 would be 60 over 180, 6 over 18. That reduces to 1 over 3. So this is a pi over 3 angle. And then we already know 90 is pi over 2, right? Okay. Those should seem familiar to you. You did this in Algebra 2 and some of you again in Algebra 3, right? We probably remember those, right? 30 is pi over 6, 60 is pi over 3, or at least that seems familiar to us. Okay. Now, there are many ways to fill out the rest of the angles in the unit circle. To kind of go along with what we're going to do with our triangles, I am going to use reference angles. So we are going to talk about reference angles later on in the chapter, but you did talk about reference angles in Algebra 2. So I'm going to go over to quadrant 2. Okay, so I'm focusing all my attention now on quadrant 2. And we do know that at this point right here, we have 180 degrees or pi radians, right? We've already covered that information, so we know that's true. Reference angles, back in Algebra 2, were an acute angle that you could find in any of the quadrants 2, 3, or 4. Okay. You just had to like backtrack from the x-axis. So you know how I have over here in quadrant 1, 30, 45, 60? Okay. I'm going to find the 30-degree reference angle in quadrant 2. I take 180 and I subtract 30 from it. 180 minus 30 is 150. So if you had a 150-degree angle, it would have a reference angle of 30 degrees in the second quadrant. Okay. I'm going to do the same thing with 45. 180 minus 45 is 135. And I'll do the same thing with 60. 180 minus 60 is 120. Okay. That is not the only way for you to fill in those angles, right? Okay, you could think this is 30 plus 15 plus 15 plus 30. So 90 plus 30 is 120, 120 plus 15 is 135, 135 plus 15 is 150, 150 plus 30 is 180. I can get around the unit circle lots of different ways. Okay, I'm just going to utilize the reference angles. Now I'm going to do the same thing with radians. So now instead of doing 180 minus those angles in the first quadrant, I'm going to do pi minus those angles in the first quadrant. Pi minus pi over 6. How many sixths are left? 5 pi over 6. Pi minus pi over 4. How many fourths are left? 3 pi over 4. 1 pi minus pi over 4 is 3 pi over 4. And pi minus pi over 3. It's like 1 minus 1/3. 2/3 is left. 2 pi over 3. Okay. Note that you could be counting fractions like little pizza pie slices. Here's a 1/6. 2/6, which is 1/3, 3/6, which is 1/2, 4/6, which is 2/3, 5/6, and 6/6, which is 1. You could also be doing conversions, multiply by pi over 180. Okay, I'm using reference angles. Then we want to fill out the bottom two quadrants. So I'm going to do degrees. 180 plus 30 is 210. 180 plus 45 is 225. And 180 plus 60 is 240. So I'm adding the angle from the first quadrant. And then I do the same thing with pi. Pi plus pi over 6. 7 pi over 6. Pi plus pi over 4. 5 pi over 4. Pi plus pi over 3. I have 4 pi over 3. We already know 270 degrees and 3 pi over 2. Okay, or that could be like pi plus a half pi, which is 1.5 pi or 3 pi over 2. And then to do this last quadrant, instead of adding and subtracting the angles from 180, now I want to add and subtract the angles from 360 or 2 pi. Because the idea with a reference angle is you always have to go back to the closest x-axis. So this is 360 minus 30, which is 330. 360 minus 45 is 315. And 360 minus 60 is 300. And then I would do the same thing with the 2 pi. 2 pi minus pi over 6. 11 pi over 6. Because to be 2 pi, you must have had 12 pi over 6. 2 pi minus pi over 4 is 7 pi over 4. And 2 pi minus pi over 3 is 5 pi over 3. So I'm going to encourage you to take some time over the weekend as you're working on your homework assignment to make sure you're comfortable with these angles on the unit circle. And there are lots of ways to see how to find those angles or where those angles are. I'm looking at it from a reference angle perspective. You could look at it from more of like a fraction perspective, a pizza pie slice perspective. You could also just look at it at what are those smaller angles and adding them up each time. Okay, so make sure you're comfortable with those things. Does anybody have any questions or clarifications before we move on? Okay, go back to your notebook. And just as a side note, I will post the unit circle, a completed one, online later today so that you can double check that you have everything correctly, all the numbers are right, that type of thing. There's also one in your textbook, or you could easily Google it and you'll find something. Okay, so the next thing we want to talk about are special right triangles on the unit circle. Basically, we are creating a shortcut for how you approached finding trig ratios of special angles in Algebra 2. In Algebra 2, think back to last year when you did trigonometry, this is kind of the way that it worked. If I gave you an angle like 225, and I said find the cosine of 225 without a calculator, you would have to make sure 225 was between 0 and 360. It is. If it wasn't, you'd have to find a coterminal angle. Then, after you make sure it's between 0 and 360, you'd have to find its reference angle. So since 225 is in quadrant 3, you'd have to do 225 minus 180. That's 45, so it has a 45 degree angle, reference angle. Then you'd have to sketch out the 45, 45, 90 triangle, label all the sides, and does anybody remember what trig ratio I said? Sine? Cosine? Cosine. I said cosine. So after you label all the sides, and you go to one of the 45 degree angles, and you find the cosine of that angle, right? Adjacent over hypotenuse. And then you had to determine, since it's in quadrant 3, would it be positive or negative? Does anybody remember how we determined positive or negative? Eric?
I don't remember the rule, but I remember like what they are.
What are they?
It's sine or cosine comma sine, and then the tangent is the two multiplied together, right?
Oh, okay, in the unit circle, yes. But I'm saying just like at the very end of your Algebra 2 work, you had to decide if the ratio is positive or negative.
Oh, wait. I got a question outside that. Is it, which one's the all students take calculus one?
That.
Okay. That's
All
what I
students
remember.
take calculus, right? At the very end of your problem, you have to do wait, I should do it the way you see it. All students take calculus, and since 225 is in the third quadrant, that's take, only tangent and cotangent are positive, so then you would have made your thing negative. Okay, so it was a lot of work in Algebra 2. The unit circle is going to make it so much quicker. Okay, so that's what we're trying to attempt in the unit circle. So, we're going to look at special right triangles on the unit circle. I'm going to draw 3 quick sketches of how we see special right triangles on the unit circle. So I'm going to draw 3 circles. Oh my gosh, I'm getting better at circles as the day goes on. That one not so good. So one of those special right triangles that we could find in the unit circle would look something like this. Okay, that's like maybe the 30-degree angle in quadrant 1. And then think about how I calculated all those angles on the unit circle. I did reference angles. Then there's something very similar to that in quadrant 2, something similar to that in quadrant 3, and something similar to that in quadrant 4. So it almost makes like a bow tie. Do you see that? Okay. And then the next one would be like a 45-degree. Okay. There's a reference angle in quadrant 2, a reference angle in quadrant 3, and a reference angle in quadrant 4. I thought I drew awesome circles, but now that I'm drawing those triangles, I realized I didn't. Okay. They should all be congruent. And there's another one that is that 60-degree. Okay, and there's a reference angle in quadrant 2, and a reference angle in quadrant 3, and then a reference angle in quadrant 4. Okay, so those are where, like, what you were doing in Algebra 2. You were finding that reference angle, you're finding that triangle over there, and then you're going to draw out the special right triangle and figure out if it's positive or negative and figure out what the ratio is. Okay, we are going to take our special right triangles, 30, 60, 90. You drew these in your notes yesterday. And we are going to simplify them for the unit circle. As you look at those triangles that I drew that sort of create that butterfly or that bow tie shape in the unit circle, if I were to go through and kind of like highlight my hypotenuse of all those right triangles, what is the hypotenuse representing in the unit circle? It's the radius. So we know that in order for these triangles, these special right triangles, to fit on the unit circle, the radius must be 1. Or sorry, not the radius, but I suppose the hypotenuse must be 1, because it is the radius. Okay. So the hypotenuse must be equal to 1 in those triangles. Well, right now, so I'm going to move this. Right now, the triangles do not have hypotenuse 1. This has hypotenuse 2, and this has hypotenuse square root 2. So what could you do, like in the 30, 60, 90, what could you do to this hypotenuse to make it equal 1? Divide by 2, or multiply by 1/2, right? If I divide this side by 2, then I have to do that to all the sides. Okay. So when you do that, it's kind of like that question Maddie asked about on the homework. She just needed a refresher about the special right triangles. They always come in the same ratio. So they don't always have to be the numbers 1, square root 3, 2. They could be larger and they could be smaller. They always have the same ratio. So if we divide that hypotenuse by 2, we have to do that to all the other sides. And this is going to be the sides for your pink triangle. So could you please find your pink triangle, handed to you by Maddie, okay, and copy those sides. The hypotenuse should be 1, the short side should be 1/2, and the long leg should be square root 3 over 2. Copy it on the front, copy it on the back. It doesn't matter how you orient your triangle or like what direction you write your text. Sometimes it'll be upside down or sideways. No big deal. Okay, so fill out your pink triangle and then flip it over and do the same thing on the back side. The hypotenuse should be 1, the short side should be 1/2, the longer leg should be square root 3 over 2. Now, we're going to do the same process for the 45, 45, 90. We need the hypotenuse to be equal to 1 so it will fit on the unit circle like it does in this picture right here. So what will we do to the hypotenuse? This time divide by radical 2, square root 2. That means I have to divide each of these sides by square root 2. And we're not going to leave our sides as 1 divided by square root of 2. We're going to go ahead and rationalize that denominator, so that's going to be square root 2 over 2. Okay. And then fill that out on your blue triangle. Do it on the front, do it on the back. No. Hopefully Miss Cushing has her. Yes, she does. Okay, now we are going to use these special right triangles then to fill out all the other coordinates on the unit circle. So please have out your unit circle and your 2 color triangles. Okay, and I'm going to show you, I'll do this butterfly or bow tie shape first. I'm going to fill out like one at a time because that to me is pretty easy. Okay, so I'm going to take my unit circle. I'm going to take my pink triangle. I'm going to find a way to fit that pink triangle. I need the hypotenuse 1 to be on this line that represents my radius, but this is not okay because it's crossing the x-axis. Do you see that? That doesn't look like that bow tie or butterfly shape. So I've got to kind of like reorient my triangle. If I just turn mine over, see how that's real nice and it looks like that part of that bow tie shape? Okay. And so what this does for me is it says from the origin to this point on the circle you have a radius of 1. But I now can very clearly see what my x and my y are. I went square root 3 over 2 to the right, and I went 1/2 up. So I can fill those into my coordinates. Square root 3 over 2, 1/2. And I now know the ordered pair for that 30-degree angle, or pi over 6. Once you have that in the right spot, just use reflections of that triangle over the different axes to help you fill out the rest of those angles. So I'm going to reflect it over the y-axis. And notice that side is still lining up with my horizontal x-axis. And then I have my right angle going up to my point. Okay. And now to get from the origin to this point over here, I can see I went left square root 3 over 2, and then I went up 1/2. So how will I write that as an ordered pair? Negative square root 3 over 2, positive 1/2. So now as you change in different quadrants, you're going to be changing the sign of your coordinate. Okay, if I reflect over the x-axis, I'm getting that bottom part of my bow tie there. And I'm going left and down, so I'm going to have negative square root 3 over 2 and negative 1/2. And then reflect one more time over the y-axis. This time I'm going positive to the right, negative down, so I'll have positive square root 3 over 2 and negative 1/2. So when I kind of look at that from a distance, and I haven't filled out any of my other coordinates, so I only have that one right now, I can see, like, you can make the connection. These are all the 30-degree angles, but I also see it really clearly with my radians. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 all have like the same coordinates, square root 3 over 2, comma 1/2. They just have different signs depending on which quadrant I'm in. Okay? So you should sort of see that pattern continue for the 45, 45, 90, and the 30, 60, 90. So I'm going to set mine up in quadrant 1. And remember, yours have to create a bow tie. Okay, so in quadrant 1, if I were going to do the 60 degree, I would need it to look like this, so that as I reflect it over all of the axes, I get a bow tie shape. Okay, and then my 45, 45 would look something like this. One side has to be on the horizontal x-axis, and then your right angle has to go up from that, so that you're getting an x and a y on the coordinate plane. Okay, would you please fill in your coordinates, and I'll be walking around. Raise your hand if you're needing assistance. Okay, fill in your x and your y. Talk to the people around you, compare, look at their unit circle, see if you have the same order pairs as you go around. Okay, I'm going to go around and fill out my coordinates just all the way around the circle, the ones that I have not yet filled out. And you can kind of follow along with me and kind of check to see that you have the correct coordinates, the correct order with the correct signs. So in the first quadrant, the pi over 4 angle should be square root 2 over 2, square root 2 over 2, both positive. The pi over 3 angle will be positive 1/2 and positive square root 3 over 2. Yep. Thank you. In the second quadrant, 2 pi over 3 will be negative 1/2 and positive square root 3 over 2. And in 3 pi over 4 will be negative square root 2 over 2, positive square root 2 over 2. Okay. What do you notice about the ordered pairs in quadrant 2? All the x's are negative. all the y's are positive. Okay, so that could help you as you're trying to like recall the unit circle on your own later. You know that there are certain patterns in different quadrants. In quadrant 3, the 5 pi over 4 should be negative square root of 2 over 2, negative square root of 2 over 2, and the 4 pi over 3 is negative 1/2 and negative square root 3 over 2. And then in quadrant 4 we should have positive 1/2, negative square root 3 over 2, and then positive square root 2 over 2, negative square root 2 over 2. Again, I'll post my completed answer key so you can go back and you can check to make sure you have all the correct coordinates if you're still working and you want to just make sure you take a little bit extra time to look. Okay, why did we just do all that work? Right? That's the big question. So go back to your notes. We're going to write one thing about trig functions, okay, on the unit circle. Thank you. Notice that there. Trig functions on the unit circle. Okay, I'm going to draw a picture again. I'm going to pick a point, x comma y. On a coordinate plane, to get from the origin to xy, I'd be going x to the left, or sorry, x to the right, y up, and then I have this short distance from point to point, which we know on the unit circle is equal to 1 because that's our radius. And so we're going to call this angle, the angle that we're evaluating on the unit circle is always right around the origin. We're going to call it t. And normally I would call an angle theta. The only reason we're going to use t here is because we're talking about something on the unit circle. So it's a special angle that's on the unit circle. So we'll say let t be a real number and really it's an angle on the unit circle. Then we can find the sine of t, the cosine of t, and the tangent of t, and it'll be a quick shortcut. So if you were to do the sine of angle t in this triangle, you'd go to angle t and you'd be looking for opposite over hypotenuse. The opposite to angle t is side y. The hypotenuse is 1. So y over 1 will always reduce to y. The cosine of t will be adjacent over hypotenuse, which is x over 1, which will always reduce to x. So that was what Eric was kind of saying, thinking ahead, that x is the cosine value, y is always the sine value. And then tangent would be opposite over adjacent, or y over x. You could also then fill out cosecant, secant, and tangent, or sorry, cotangent. They're just the reciprocals. So 1 over y, 1 over x, and x over y. Okay. Now, let's put that to use on the unit circle then. Okay, so I'm going to do an example. Find the 6 trig ratios for t equals 5 pi over 3. And we're not going to do all the work that we did in algebra. What we're going to do is use the information that we just wrote down about trig functions on the unit circle. Sine is equal to y. Cosine is equal to x. Tangent is equal to y over x. Okay. So go to your unit circle and locate 5 pi over 3. In which quadrant is 5 pi over 3 located? Oh, fourth quadrant. It's the same as 300 degrees. What is the ordered pair for 5 pi over 3? 1/2 negative square root 3 over 2. So I'm going to go ahead and write that down in my example. My ordered pair is 1/2 negative square root 3 over 2. So that's my x and that's my y. If I want to do the sign of 5 pi over 3, which is on the unit circle, then if I look back at my notes, I know that sine is always equal to y. So the sign is negative square root 3 over 2. Cosine is always equal to x, so that would be 1/2. And tangent is equal to y over x, which when we divide by that fraction, we'd multiply by the reciprocal. Negative square root 3 over 2 times 2 over 1. So that's negative square root 3. And then you could do the reciprocals. Cosecant, I would just flip that negative 2 over square root 3 and rationalize negative 2 square root 3 over 3. For secant of, 5 pi over 3. I can fill that in. 5 pi over 3. I would flip 1 over 2, which will just be 2. And then for cotangent of 5 pi over 3, I will flip the negative square root 3. So that's negative 1 over square root 3, which will be negative square root 3 over 3. And I have my 6 trig ratios. So this is supposed to cut out a lot of our work. And in the beginning, for those of us who haven't seen the unit circle before, you'll be doing, like on your homework, a lot of referring back to the circle. But know that on Friday's quiz, for quiz 4.1, 4.4, I'm going to ask you questions from the unit circle, which you should be able to answer without the unit circle in front of you. So you need to be doing your homework assignment and thinking about, like, can I call these to the front without having to look at the unit circle? That probably won't happen right away, but the more you do your practice, the better at it you'll get. Okay, and I'll give you some pointers for how to do trig functions later.
Would you please stand for the Pledge of Allegiance?